Good morning. We're going to continue on with our last method for graphing quadratics. You'll remember the first one was graphing in vertex form, which was when your parentheses had a square on the outside. The second one was in standard form, so ax squared plus bx plus c, which is very familiar from the quadratic formula. And then the last method is when they're in intercept or factored form, and I've seen it called both. I tend to call it intercept form because you're finding your intercepts. But this kind of goes back to what we were doing when we were solving quadratics by factoring. Okay, so that's why you'll see it called factored form. If we have something in intercept form, there might be a coefficient out front, like a GCF that they factored out, but the two numbers that are inside the parentheses are actually going to give you your x-intercepts. And then you can add those together and divide by 2 to find where your axis of symmetry is, and then use that to find your vertex. It makes more sense when we go through it, so let's go ahead and do a couple examples. Okay, so for the first problem here, you'll notice that we have a factored form here. The intercepts are going to be the opposites of this. So think back to when we did x plus 2 equals 0, and we subtracted 2 from both sides to get negative 2, and x minus 4 equals 0, and added 4 to both sides to get x equals 4. We were finding the x-intercepts of the graph when we were solving like that. So we have x-intercepts at negative 2 and positive 4. To find the axis of symmetry, you can do this mathematically off to the side, or you can find the middle of your graph between those. So I noticed that these are 1, 2, 3, 4, 5, 6 units away. So halfway between would be right there, which is at 1. So you can definitely do it using your graph. Your axis of symmetry is x equals 1, doing it that way. Or you can add the two together and divide by 2. So negative 2 plus 4 is 2, divided by 2 is 1. Same answer, either way. And then to find your vertex, we're going to plug in 1. So 1 plus 2 times 1 minus 4 gives us 3 times negative 3, which is negative 9. So our vertex is actually at 1, comma, negative 9. So we're going to plot that. In this case, you don't have to make a table because you actually have enough information there to sketch a rough graph. And I'm going to apologize because this is going to be a really rough graph here. My coordination is off. I'll try one more time. There we go, closer. But this is actually one of my favorite ways to graph. Let's do another one. Okay, notice again, these are in parentheses. The numbers are the same, I apologize for that, or similar. So think of this, x minus 2 equals 0, and x plus 4 equals 0. So we get a positive 2 there, and a negative 4 there. So my intercepts are at 2, 0, and at negative 4, 0. 1, 2, 3, 4. Again, axis of symmetry, you can add those together and divide by 2, or you can just count it on your graph. So notice that it is at negative 1 this time on my graph. And then my vertex is going to be using the axis of symmetry and plugging that in to find our y. So we have negative times negative 3 times positive 3, which gives us 9. So our vertex is at the point negative 1, 9, which is up here. I apologize for my parabolas in this. And that's it for that. Okay, 2 guided practice problems. Go ahead and do those 2. Whoops, too low. And check back to check your answers, and you should be good after that. Hit pause, and then hit play again when you're ready. Okay, go ahead and check your graphs here. Again, I didn't show my work, so if you want us to go through that, please let us know, and we will happily help you with those problems. But your graph looks like this. You have intercepts at negative 3 and 1, axis of symmetry at negative 1, and then your vertex is down here at negative 8. Second one, we have points on the x-axis at negative 2 and positive 4. Axis of symmetry is at 1. And then this 1/2 here takes that and actually kind of smashes the graph down compared to the one above it. Okay, so that's what your 1/2 does. If you have any questions, let us know. If not, continue graphing and have a great day.